Right now, as you sit here, faint starlight is being pulled apart inside a machine a million miles from Earth. That light left its home before you were born. It has been traveling ever since, and tonight a telescope is sorting it, molecule by molecule, looking for one thing. It is not a rumor, it is not science fiction. It was found before the story ever reached the news. The signal itself is almost nothing. A dip in brightness smaller than a moth crossing a stadium floodlight, seen from clear across the city. That flicker is the whole of it, and yet inside that flicker sits a gas that here on Earth is made almost only by living things. The word the researchers reached for was biosignature, a fingerprint of life. This is the story of K2-18b. What that faint gas might mean for the oldest question we have asked, what scientists are still arguing about right now in 2026, and why only one instrument in existence can even attempt this. Stay with me, because by the end you'll understand why the most important word in this story is wait. If you watched Apollo lift off or waited up for the Voyager launches, this channel was built for you. Subscribe. What comes next is a story that rewards patience. That quiet announcement came in 2023. A team led from Cambridge pointed the newest, most expensive telescope ever flown at a dim red star in the constellation Leo. Not to make history, to do chemistry. Their job was ordinary in its way. Catalog the gases in a distant planet's air, read the light, name the molecules, write it down. Nobody sat down that season expecting a headline. Picture the work. An astronomer at a screen staring at a spectrum, a jagged line of peaks and dips, each one the signature of a different gas. You learn to read it the way a mechanic reads an engine by sound. Methane here, carbon dioxide there, the familiar fingerprints of a working atmosphere, and those came through clean. Methane clear, carbon dioxide clear. A real result on its own, worth the years it took to get there. But there was a third wrinkle in the line, small, easy to miss. The kind of bump that usually turns out to be noise, the random static every instrument carries. It should not have been interesting, it was. Now hold the planet itself in your mind for a moment. K2-18b. It sits 124 light-years away so far that the light we're reading tonight began its trip before most of us learned to walk. It catches roughly the same share of starlight that Earth does. And beneath a thick hydrogen sky, some believed, there might be a warm ocean. Water, the one ingredient we always look for first, an ordinary survey, a routine reading, and buried inside it, almost lost in the static, something nobody was supposed to find. That faint third wrinkle had a name, and the name is what changed everything. The name was dimethyl sulfide, DMS for short. And on Earth, that gas has a very particular source. It pours off the ocean. From plankton, the tiny drifting life that fills our seas. When those organisms live and die by the trillion, they release it, and the salt smell you catch at the coast is partly them. Almost nothing else makes DMS in any real quantity. Not weather, not rock, not fire. Life makes it. Here, that is the rule. So picture what it meant to find even a hint of it in the air of another world. The 2023 signal was faint, a whisper. The team was careful, and the wider field was skeptical, and that was right. But they went back. In April of 2025, they aimed Webb's mid-infrared instrument, the part of the telescope that reads heat-colored light the eye can never see at that same distant planet. And the whisper seemed to grow louder. The signal firmed up to what scientists call 3 sigma, not proof, but strong enough that you could no longer wave it away. Sit with the strangeness of that. A mission built to catalog gases had walked straight into the one gas nobody wanted to say out loud. On one side, a single faint line of light. On the other, the largest question a human being can ask. And if that gas is truly there and truly made by living things, then this does not stay 124 light-years away. It reaches all the way back here to what we thought we knew about being alone. But before you can trust a signal like that, you have to understand how the telescope actually sees a gas it can never touch. The honest answer is that the telescope never touches it at all. It reads a shadow. Here is how. That planet does not sit still. It circles its star, and once each orbit, it passes directly between the star and us. Astronomers call that a transit, the planet crossing the face of its sun, like a small dark coin sliding over a lamp. And in the moment it crosses, something quiet and beautiful happens. Starlight streams past the planet's edge and filters through its atmosphere first. Think of light pouring through a stained glass window. The glass does not block the light, it changes it. Each pane drinks its own particular colors and lets the rest through. Gases do the same. Every gas swallows a few specific colors of light and leaves the others untouched. Scientists call that absorption. When Webb spreads the incoming light into a spectrum, the full rainbow of colors, laid out in a row, it can see which colors have gone missing, and from the gaps, it works backward to the ingredients. Missing colors here mean methane. Missing colors there mean water. That is the whole trick. You read the light by reading what the light has lost. But here is the catch that matters. The colors DMS removes sit very close to the colors that plainer, more boring molecules remove. Very close. So telling them apart is not like spotting a familiar face in a photograph. It is like standing in a loud, crowded room, straining to pick out one particular voice while 100 others talk over it. And it was exactly that noisy room where the trouble began. Other scientists heard that one voice too. So they went back to the same recording, the same Webb data, and listened again with their own settings, their own methods, and the models began to wobble. This is where the story turns. The Discovery team had built their analysis a particular way, and built that way, it favored DMS. But a spectrum is not read once and closed. It is read and reread by rival teams, each making its own reasonable choices about how to handle the noise. And when those other teams ran the numbers, something unsettling happened. The gas kept vanishing. One independent group re-examined the data and found the methane still standing strong solid, undeniable. But the DMS? No firm signal at all. Under their method, the thing everyone was talking about simply wasn't there. Another group went further. They showed that a far more ordinary molecule could explain the very same wrinkle just as well. Ethane. A plain, unremarkable gas one we already know exists on worlds right here in our own solar system. No life required, no ocean of plankton, just chemistry we've seen 100 times before. So look at what the real question had become. Not is there life out there? Something colder and sharper? Is the signal even real, or is it a shadow cast by how we chose to look? Same telescope, same light, same distant planet, different hands on the dial, and the answer changed. That is not how a discovery is supposed to behave. But here is the part of this that stops being abstract and starts being personal. Personal because this is about you, about all of us. For the whole of human history, one question sat above every fire and every rooftop. Are we alone? Every generation that ever looked up has asked it. Your grandparents asked it. Theirs did too. And for all those thousands of years, it was philosophy. A question you could wonder about, but never test. That has changed. Right now, in 2026, it is no longer only philosophy. It is an engineering problem. There is a telescope pointed at a specific dot in the sky, a planet with a plain catalog number, and it is putting real numbers on the oldest question we have. Think about the distance between those two things. A question as old as our species and a machine built within your own lifetime, finally able to reach for the answer. Whatever that answer turns out to be, even if the gas fades to nothing, something has already shifted. We can ask now, really ask, with instruments, not just imagination. We do not yet know exactly what that means, but the fact that we now need to ask the question at all is itself a change in how we see ourselves, how small we are, and how strangely significant. And that is exactly why what a handful of rival scientists did next matters so much. What they did was try to tear the discovery apart. On purpose. Picture two camps. On one side, the team from Cambridge, confident in years of careful work, certain they had found something real. On the other, independent groups, one at Chicago, others scattered across the field who took the very same Webb observations and set out, deliberately, to break the result. Not out of spite, out of duty, because that is how the system is supposed to work, and the bar in front of all of them was brutal. The scientific community will not accept a claim of life on anything less than what they call 5 sigma. That means the odds of the signal being a fluke must fall below 1 in a million. 1 in a million. Nothing less will do because the claim is that large. The DMS signal never got close. It kept landing near 3 sigma, sometimes lower around 2.7, strong enough to make your heart race. Nowhere near strong enough to stake the reputation of a science on. Now feel the weight on both sets of shoulders. Announce too soon, and you damage the credibility of the entire field for a generation. Every future claim doubted because of yours. Stay silent, hold back, and you might be the one who let the biggest discovery in human history slip through your fingers. So they argued, in public papers, in careful language, in print that anyone could read. The Chicago team held to a simple principle. The goal is proof, not excitement. Get it right, not first. That is not a failure of nerve. That is the job at its most honorable men and women, making sure that if we ever say the words "we are not alone," the words will hold. And here is the hard part. There is exactly one machine that can even referee this fight. One. No replacement is flying. Now the story gets stranger because even after all that arguing, the planet itself refused to be ordinary. Set the fight aside for a moment, because underneath all that arguing, something solid was standing the whole time and almost nobody noticed, because the word life was louder. Here is what is not in dispute. Whatever the truth about that one contested gas, Webb confirmed real things about this world. Its air holds methane, it holds carbon dioxide, and it is rich in water. By some analyses, water may make up a staggering share of the planet's very mass, not a lake, not a sea, but water woven into the substance of the world itself. Sit with the picture that builds, a warm, water-laden planet, possibly wrapped pole to pole in a single global ocean beneath a hydrogen sky, circling a dim red star so faint you could never find it with your own eyes on the clearest night of your life, and we are reading the air of that place from 124 light years away. Stop and let the size of that settle. We are naming the gases in the sky of a world we will never visit, never photograph, never reach. Not guessing, measuring. Think of the young engineers of the 1970s, bent over drafting tables, building rockets by hand, slide rules in their shirt pockets. If you had told them that within their own lifetimes we would fingerprint the chemistry of an alien sky across that gulf of space, they'd have called it fiction. Pure fiction. It is not fiction. It is Tuesday for a working telescope. Think about what that actually means for where we stand right now. Section 10, Act 8, The Present Situation. So where does it stand tonight in 2026? Honestly unfinished. The claim of dimethyl sulfide is not confirmed. By the weight of the independent work, it is not currently supported at the level real science demands. But hold this carefully. It has not been ruled out either. The signal did not die. It faded into that noisy room, waiting for a cleaner listen. The path forward is plain, if not easy. More time on Webb, more transits watched more patiently, better methods for pulling one voice out of the crowd. Somewhere in that quiet gap between silence and signal, the answer is waiting to be heard. But here is the grief in it. There is only one Webb. It runs on a finite budget of fuel and an instrument no hand will ever repair. No astronaut is coming to service it. Every hour it spends staring at this one planet is an hour it does not spend somewhere else in the sky. Time on that telescope is the rarest currency in science, and settling this will cost a great deal of it. And yet, the team is cautious. They are making no promises, but they are still looking. And the telescope, barring the worst kind of luck, should keep working into the late 2030s, years of listening still ahead of it. The window to answer this falls within this decade, on this one machine. Now come back to that faint gas, because there is one more thing that deserves to sit at the center of this story. That one thing is not the gas at all. It is what we did when we found it. We found the most exciting hint in the history of our species, a possible sign of life on another world, and then we refused to celebrate. We doubted it. We tried to break it. We held the champagne on ice and went back to the data again and again, because being right mattered more than being first. That restraint is the real monument here, not a telescope, a temperament, the mark of a civilization grown up enough to want the truth more than it wants the thrill. And it is a form of respect. Respect for the truth itself, respect for the people who built the machine, respect for whoever inherits the final answer. Now say the hard thing plainly. Many of the men and women who built the space age will not be here when that answer comes. They laid the rails and the train arrives after dark. The discovery may belong to the future, but the discipline, the patience, the honesty, the refusal to lie to ourselves, that belongs to them. So here is what I want you to carry out of this. The headline said life. But that was never the real story. The real story is a machine and a community doing something harder than discovery, earning the right to be believed. Look again at the scale of it. One faint line of light, argued over by rival teams in careful papers, set against the largest question a human being can ask. And understand what the waiting really is. The willingness to hold back until you are sure is not weakness. It is curiosity in its highest form, curiosity with the discipline to deserve its answer. This is being decided now. On one telescope within this decade, one planet, one faint gas, one question we have asked since we first looked up. And if the answer does come, will we have been patient enough to trust it? If this moved you, subscribe and turn on notifications so you're here when the answer arrives. Then tell me below, where were you when the space age began, and did you ever think we'd get this close? And send this to someone who'd want to know.